Hello dear students, welcome to Shoros's classes, and this video is dedicated to a specific test of econometrics. As I said in the last one, today we will be doing Durbin Watson Test. So Durbin Watson is given this test in order to test the autocorrelation of a given structure. Okay. So presence of autocorrelation. So what is autocorrelation? So autocorrelation, we can think that in a discrete structure, correlation among the explanatory variables, which is not at all expected. Okay, and as a result of that, the prediction about one variable cannot be completely independent of the other, so which makes it a completely systematic failure. So now whether the failure is there or not, so Durbin Watson did a great job. There is another test of it, von Neumann test, but that for larger values not applicable, but this one is. Okay, especially applicable for regression analysis. Names of the full people is James Durbin and Geoffrey Watson. Okay, now the null hypothesis, or the H0, or the expected thing, is that the errors are serially uncorrelated. The errors in a system are uncorrelated. Now in presence of autocorrelation, errors are related to each other. So there is a progressional structure of auto-regression. So the system from its own way proceeds without following the orders from outside. Okay, so how we can compute? Let ET is the residual. Okay, we talk about the residual in the form like ET. Let ET equal to residual given by rho ET minus 1 and VT. So here the subscripts are actually talking about present and one time period back. Durbin Watson states that the null hypothesis is rho equal to 0. So ET equal to VT comes in directly. Clear? Alternative hypothesis is this rho not equal to 0, H0, and this is the H1. Now let's talk about the test statistic. The test statistic is by which we go for this. D equal to 2 to T ET minus 1 square by summation of T equal to 1 to capital T and ET square. Now what is this T? So T is the, here T equal to number of observations. If one has a lengthy sample, then this can be linearly mapped to a Pearson correlation of the time series data with lags. So a Pearson correlation can also be done here. D is approximately equal to 2 into 1 minus rho hat, that is estimated value of the rho, and rho hat is the sample autocorrelation of the residual. This is the sample AR. Clear? D equal to 2 indicates there is no autocorrelation. The value of D always lies between 0 to 4. Clear? If the Durbin-Watson statistic is substantially less than 2, so there is an evidence of positive correlation. So D is very low, so positive R. Okay. As a rule of thumb, we can say that Durbin-Watson value, the D value, is less than 1. There may be a cause for alarm. Okay. So if D less than 1, cause for alarm. Small values of D indicate successive error terms are positively correlated. So errors are related and positively correlated. If D greater than 2, that means successive error terms are negatively correlated. Okay, so this is very important. Let's talk about it in a elaborate way. if DL equal to lower critical value and du alpha is the upper critical value. So if D value is less than D and alpha, so there is statistical evidence that the error term is positively correlated. Yeah. But if D greater than D of L u comma alpha, then it is no statistical evidence or no correlation. But if this lies between these two, then what happens? Lower D and upper. So the test is inconclusive. Clear? So this is the formation. Now for negative correlation, this is for the whole thing for the positive correlation. So for the negative correlation, 4 minus D is compared. So 4 minus D, the maximum value, D of L comma alpha. So that is where there is a negative correlation obviously. And if it is greater than this upper limit, no. And if it lies between these two, then also it's a cause for an alarm. Okay. So in the third case, we have u comma alpha. Clear? So this test is inconclusive. So negative serial correlation implies that a positive error of the observations are there. Okay. Now there is another thing, Durbin H statistics we also call it. So Durbin Watson statistics is based for autoregression, we know. So there is a H value we can calculate from this utilizing this D. Let me just tell you, this is D minus 2 T by 1 minus T variance of beta 1 hat. So this is using the Durbin Watson statistics D and the estimated value. So we can see that the variance of beta 1 hat of the regression coefficient of the lagged dependent variable, and this, the T into this product is less than 1. So you can do this in any R, MATLAB, Mathematica, SAS, eViews, Gretel, Stata, Excel, Minitab, Python, SPSS, Julia, in all this kind of thing, and for hypothesis testing structures. So any kind of computer related problem or it gets stuck, feel free to ask me at this number via WhatsApp. If you are outside India, then you can also do a video call to me. So I will try my level best to solve your problems. So that's it for today. Thank you.